Okay, hello everyone. My name is Tally Klawicki. I am the chapter lead for the Unreal Orlando developers community. And today for our July event, we are going to be hearing from Brad Spearing with Ternion Company. He is going to be giving us a demo of their advanced simulation framework, Flames. But before we get into that, I'm just going to give us a couple of announcements. So we just had our first meeting for the group of developers that are going to be participating in the Armed Forces Game Jam. However, I'm going to say that there is still time to sign up and participate if you guys are interested, or if you know anyone who's interested. Feel free to reach out to me after the event. You can email me at tklewicky@ara.com to get more information on that. Additionally, next month, I think on August 18th, we are going to be having another in-person meetup. And we're going to be going on a studio tour around Green Slate Studios, as well as seeing a really, really cool collaboration project between TerraSynth and Green Slate, where they are going to be showing us how they are able to create really awesome real-world AI geospatial graphics and then put them on a green screen, and then you can stand right in there and be filmed and very quickly stand right in the 3D space that you have just developed. So I'm really excited, looking forward to that. It's going to be super cool. Again, that's going to be August 18th from 2 to 5 p.m. So yeah, if you're interested in that, we'll be posting more about it in the coming weeks. And other than that, I'm just going to go ahead and let Brad take it away. And I will go ahead and give people video and audio presentation or video and audio permissions, because I have to enable those manually for you guys. So yeah, go ahead. Looking forward to it, Brad. Oh, and you're muted right now.
Okay. So what I'm going to do is try to get through the presentation and demo within about 35 minutes so that we'll have time at the end for questions, the last 15 or 20 minutes for questions. My name is Brad Spearing. As Tally mentioned, I'm the president and one of the co-founders of Ternion Corporation. And I'm also the product manager for the product that I'm going to be telling you about today, a product that we call Flames. We have been in business since 1989, and we started the company specifically to develop the thing that I'm showing you today. That's the core of our business. It's always been the core of our business. Again, it's what we started the company for. And we have two divisions. One division is what we call the software products division, and they focus on developing Flames. It's a commercial off-the-shelf product. And we get our revenue from selling licenses to Flames, so it's a pure product company. And then the other side of the company, the engineering services division, takes contracts, usually from government contractors or from other government agencies, either domestic or international, to develop simulations. So we develop turnkey simulations for people, but all the simulations that we develop are all based on Flames. So even the services side of the company is heavily based on Flames. So we're just Flames all the way through. And we have customers, all the U.S. Armed Force Services have used us, lots of international work, and then lots of government agencies. So I'm going to pause this presentation for just a second. I'm going to show you a quick video of a demo of our software right from the very beginning, so you know where this presentation is headed and what it's going to look like, what I'm going to be talking about. So this is a demo that was created with our software with the Unreal Engine integration. And I'm going to it's got sound, but I'm going to turn that off just so that I can talk. ARA actually built this terrain for us. And it was something that we put together for ITSIC, and they actually helped us with the other parts of it with the integration as well. So this is our Flames application called Forge, and I'm going to give you more information about that in the presentation. And we're going to do other demos of Forge, but we're actually running Unreal Engine directly inside of Forge. And we get a 2D view of the scenario and a 3D view and a 2D view. So we get sound effects, everything. This is a true Unreal Engine generated display. All of the players in this scenario that you see here are actually created in Flames, and most of the behaviors are actually being simulated in Flames. So this is what I'm going to be talking about in this presentation, is the way that we integrate Unreal Engine with Flames. Of course, the display is being done by Unreal Engine, the terrain is being done by Unreal Engine, and the actual movement of those players is being done by Unreal Engine. So we call those players hybrid players, and I'll tell you what that means in a minute. But most of the behavior is done by Flames, but the platform, the vehicle is being done in Unreal Engine. So you get all of the physics and effects and sound and everything. That's for the ground vehicles. We modeled those in Flames. The air vehicles we modeled the ground vehicles. They're in Unreal. Excuse me. The air vehicles, this Osprey and the helicopter, those are actually modeled entirely in Flames. So we're going to talk about the different ways that you can choose to model some things in Flames and some things in Unreal, and how you can do that together. So again, I wanted to show you a quick demo of what it looks like when it's finished. And then now what I'm going to do is go back and tell you what's really going on behind the scenes here and what you're looking at. So I'm going to close this video off. And because this presentation is being videotaped, I'm going to go through these slides really fast. I'm not going to take time to explain them. I don't really have time to go through this whole presentation in detail. But when you're playing it back in video, you can pause it and look at the slides and look at them for a longer period of time than I'm going to talk about here. So first, I know you all are very familiar with Unreal Engine, but you probably haven't heard anything at all about Flames yet. So I'm going to give you an overview of Flames. I'm going to skip this part. You probably know about the differences between live, virtual, and constructive simulations. Flames is a framework for building constructive and virtual simulations. I'm going to skip these slides right here. Again, these are slides you can pause the video and read. This kind of explains why people use Flames, and the bottom line is time and money. Being able to build a very sophisticated, high fidelity simulation with the least amount of time and money possible. Since you guys know Unreal, Flames is like the Unreal Engine of the simulation world. It's a platform for developing simulations. And that's what this thing is all about. Flames is not a simulation, just like Unreal Engine is not a game. Unreal Engine is what you use to build games, and has lots of tools in it to be able to build really cool games very quickly. Flames is the same way. It's not a simulation. It doesn't simulate any tanks, any airplanes, any helicopters. It's a framework, a platform for building simulations. So we call them Flames-based simulations, just like you would call it an Unreal Engine-based game. And so this is what we mean by the framework. It has it's just like Unreal Engine. It has all of the building blocks that you need for building a simulation, as well as end applications that you can use to edit and execute the simulation. All of the players in the simulation are implemented in plugins that plug into the outside of the framework. So that's like the project that you have in Unreal Engine. You're building up your assets. Those are not going into the engine themselves. They're things that are getting built when you build your game in combination with the engine. So same way you write code for Flames, it's written in C or C++, and you build it and it becomes a plugin for Flames. And so all of your behaviors for airplanes and tanks and communication and command and control and engagement modeling are all being done outside of Flames in these plugins. And we'll talk more about how you develop those in a minute. So the way you get a different simulation is you just plug in different plugins into Flames, and Flames is the same for all the simulations. So the point in the simulation world is, instead of building separate standalone simulations, just like you could build games from scratch, instead you build all your games in Unreal Engine the same way you can build all your simulations based on Flames. And so the unique part of each simulation is the smaller part of the simulation. The Flames framework provides the bulk of the functionality that you need to create a simulation. So this is just all the different ways that Flames can be used. I'll skip over this slide. And so now I'm going to jump into the more details about what Flames really looks like. And we have two primary products. We call one the Flames engine and the other one the Flames developer. The Flames developer is very similar to Unreal Engine. It's a development environment that you use to write software to create a specific simulation. I'm going to continue to compare it to Unreal Engine because I know you guys know about Unreal Engine. It's a little bit different, though, in that we don't have our own development environment. We use Visual Studio entirely, so we don't have our own environment. What you create from the Flames developer is plugins that you run in Flames. When we run Flames, we're not actually rebuilding the simulation like the Unreal Editor does. Flames is an executable that already has all it needs to be able to run. The plugins that you build are DLLs. When you run the Flames applications, they dynamically load the DLLs. So you're not rebuilding the Flames applications. You're just building the DLLs and they get loaded dynamically. So there really isn't a direct equivalent in the Unreal Engine world for the Flames engine. You might consider this in the Unreal Engine world like the cooked game. So this would be the Unreal Editor where you're building the game and you cook it and you get a runtime version of the game that you can run. So the engine applications are, the main one is Forge, and that's a scenario editor. We're going to spend a good bit of time in a demonstration of Forge. And then we also have a playback environment and an application called Fire, which can execute the simulation, execute the game with headless. So it doesn't have any graphics at all. So that would be suitable for a server environment. So there's a whole bunch of extra features that I'm not going to spend a lot of time talking about. You can get on our website and look at that. But we have a bunch of things that are already built into Flames off the shelf, including support for HLA and DIS, if you're familiar with that, that's built into Flames. SIGI interfaces, a whole bunch of other stuff. So I'm going to jump now and talk about the Flames developer. Flames developer, again, is something that you use to build plugins for Flames. It's basically just a bunch of include files and libraries that you use that you link to in a Visual Studio environment. The developer includes a free version of the Flames engine. And in fact, the Flames developer itself is free. So just like Unreal Engine is free, the Flames developer is free. So you can download it from our website, and I'll show you how to do that at the end of this presentation, and install it and start building Flames-based simulations from it with it without any cost at all. And the engine is something that you do have to buy a license for, but a free trial version of the engine is included with developer. And it's not a time-based trial like a lot of trial software is. The trial version is valid for as long as you have the Flames developer. So it goes along with the free Flames developer license. The way it's limited is in capacity. So you can only create games that have 10 players and that can only run for 5 minutes. So as long as you're within that bound, you can use it for free. As soon as you want to do something real with it and run it in a larger environment, then you have to buy a license. And the license is sold on an annual subscription basis. And a runtime license for the engine starts at $3,000 a year. So you can have all your developers all developing and testing their code with the free developer, and you only have to put the engine on the machine where you're going to run your final application for your customer. So here's the way that you use Flames Developer to actually develop a plugin. So Flames comes with a lot of items in our store, and I'll show you our store before we're done. The online store has lots of things that you can download, as well as not only the Flames products, but a lot of different content that's already built. And we also have a lot of source code for components, for models that plug into Flames. In fact, all the source code to everything you're going to see here today is available, and it's all available in GitHub repositories. So you can join the Flames organization just like you join the Unreal Engine organization. You get access to all of our repositories. There's, I think, 7 or 8 of them out there right now. You can pull those down and put them in a Visual Studio project that is set up for you automatically by Flames. You can start the Visual Studio project, and you can edit that code directly, or you can use a tool that we have that we call the component copier. And that is what you would use if you want to make a copy of one of our existing models and then change the name on it and make whatever changes you want. Or so you could either modify the code in the repository directly, or make a copy of something like a copy of a sensor, or a copy of a fixed-wing airplane, or a copy of a missile, or a copy of a pilot cognition behavior model. There's dozens of models in there. They're all C++ classes. So you can pick one of those classes and make a copy of it and create a new class. You take that code and you put it in Visual Studio. That's the standard development tool. So again, Flames creates the Visual Studio solution for you. When you install it, you clone the GitHub repository, and that code comes in a Visual Studio project. So it's not just plain code. It comes already in a Visual Studio project out of the repository. So as soon as you clone it, you just add that project to your Visual Studio solution, and you're good to go. You're ready to start doing software development. When you compile and link your code, what comes out of that code is a DLL, just a standard vanilla Windows DLL. And that DLL gets put in a certain folder, and we tell Flames applications which folder that DLL is located in, and the Flames applications will automatically go out and load those DLLs dynamically. So you don't have to, Forge doesn't get rebuilt. There's only one version of Forge, but it totally changes based upon the plugins that are loaded in it, and those are plugins that, again, that you get to develop. There's a bunch of already built binary versions of plugins in the Flames store, and we're going to be using some of those in this demo today, so you can get started right away with a lot of functionality. And then when you see something you like, you can go get the source code to it and make changes to it. So this is all just Flames without Unreal Engine. So I'm going to start telling you now where Unreal Engine fits into it and into Flames, and that's what we really want to get to. So Flames exists and has existed for many years without Unreal Engine, but Unreal Engine just adds a tremendous amount of capability to Flames, and we're real excited about that. So I'm going to really quickly show you where Unreal Engine fits in. So these are things that are available in Flames, and these green boxes, the Earth model, that's the shape of the Earth, the terrain, the features like the buildings and trees and stuff. Those are things that come in the Flames environment, the Flames engine. Atmospheric conditions, effects, and airspaces, those we have models of those, but you can write your own and plug those in. Then the players, they all have a whole bunch of different models attached to them. So players always have a cognition model. That's the human part, the human brain of the player, like the pilot model or the tank driver or the human brain of a dismounted soldier. That's what controls everything. It's our equivalent of the Unreal Engine AI model. We call them cognition models. The platform is the model that moves the unit, the player. So it's the vehicle. It would be the tank or the airplane. It would be the human body of the soldier if it was moving around. The platform has a signature on it. So if, for example, if it's an airplane, it would have a radar cross section. It'd have icons for how it gets drawn, and then you can have all this other stuff that goes on it: sensors, weapon systems, munitions, comm devices, and you can build up a very sophisticated, very realistic representation of some real world system. So when we have Unreal Engine, what we're doing is this: we have just regular flames, but what we've built is something that takes a game that you build in the Unreal Engine editor, just a normal Unreal Engine game, and you create a cooked game. And as you probably know, Unreal Engine can cook a game into a DLL. That's a relatively new feature of Unreal Engine. Instead of creating an executable, it can create a DLL. And that was actually the thing that made it possible for us to be able to integrate it into Flames, is that they came up with this capability. So from the Unreal Engine editor, when you cook the game, you get a DLL, and Flames has a plugin that is a Flames product that you enable and use, and that plugin talks to the cooked game. So when we load this plugin, we actually load the game DLL directly into the Flames application. So Unreal Engine is directly inside of Flames when we run. It's not running as a separate standalone executable. Now, when you're running multiplayer, Flames would serve as the listen server, and the clients would be just plain vanilla standard Unreal Engine client applications, and they could talk to the game using the Unreal Engine multiplayer capability. So when Unreal Engine is loaded, when we have the game loaded directly in Flames, the terrain and the features that we use in the Flames scenario come directly from Unreal. So there's not two copies of the terrain. The terrain that is built in the game, like you saw in that video demonstration, that is the terrain that is being used for all the mathematical operations inside of Flames. There's just one terrain. And now we have the ability to use Unreal effects, blast effects, damage effects, visual effects, sound effects. Everything that Unreal can do, they're now able to be part of the scenario, just like you saw in that scenario that I had before, the dust and the clouds and the sound. I had the sound turned off, but anything that Unreal Engine can do is fully accessible in a game that you integrate into Flames. The real magic comes in when you start building players. And I'll answer questions about this if anybody has any questions afterwards, but I'll just tell you real quickly, there's 3 different kinds of players that we support. And we're going to look at what does a player look like on the Flame side and what does it look like inside of the game. In the game, we're going to call them entities. You might call them actors but in Flames, you can have a player that is totally simulated by Flames. So everything about it, including the platform, is being simulated by Flames. A surrogate representation of that will be created inside the game. So it's there in the game. You can see it. That helicopter was an example of that we saw in the demo. It was totally simulated by Flames. The helicopter's motion was being simulated by Flames, but there was a UE entity that was instantiated inside of the game to represent it, and it's a slave to the motion of the vehicle inside of Flames. You can have the opposite. You can create a normal autonomous Unreal Engine entity and build all of its behavior in Unreal Engine, just the way you would build anything else in Unreal Engine. And a surrogate representation of that would be created in Flames. So we'd be able to see it in Flames. We could detect it. We could shoot it. So it would be a full participant in the Flames scenario, but all of its behavior is being modeled inside of Unreal Engine. The real powerful one is what we call a hybrid. So everything about the unit, the Flames player, is being simulated by Flames except for the vehicle. And the vehicle is being done inside of Unreal. We recommend doing that for things that move on the ground, individual humans, vehicles, because doing that realistically with physics and interaction with the ground and collision modeling and all that stuff, Unreal is just outstanding at being able to do that. So all of the ground entities that you saw in that scenario earlier, those were all hybrids. So a hybrid looks like this. So this is the slide I put up earlier with all the different kinds of models that are used to make up a player in Flames, a unit in Flames. When it's a hybrid unit, everything is the same. All the cognition modeling is being done in Flames. Everything else is the same. What's different is the platform model. The platform is being simulated within Unreal. So those individual human motion is being done by an actor inside of Unreal, but the actor is being controlled by the cognition models inside of Flames. So that's the theory behind it. I want to run. I think that's enough. I want to actually pull up a demo now and finish this. So this is the Flames launcher. We have an online store that has just a bunch of stuff in it. It's not as big as the Unreal Engine marketplace, not yet. It's only been online for 6 months. So there's Flames has been around forever, but this online store is a new thing for us. So you can put stuff in the cart and check out. And so if you, in fact, let me just tell you real quickly how to get to this launcher, install it on your computer. If you go to Flames Framework, there's all the information about Flames. And if you go to download Flames, it will send you to a page that will give you the download for the Flames launcher. Just like installing the Epic Games launcher, it's the same paradigm. So you'll get this store right here. Then you can put the developer in your cart. It's free. You can go down and install all these content. This is all free. You can put all that in. You create those things, then get into your library. So I've got a bunch of stuff in my library. I can download and install things from the library page. I then create projects in my launcher, so I can have different versions of Flames with different content, just like an Unreal Engine project. But again, we're not. This is a project for running as well as for building. So here's my beta project, and I can crank up this is installing the 22 beta version of Flames, because that has the Unreal Engine option. We have not yet officially released the option. We keep saying next week. It's probably not going to be next week, but maybe the week after. But it's available in beta, and anybody who wants to, we can sign them up as a beta user, so you'll get full access to it right now. So these are all the different Flames applications. One of them, this is not Flames, you can start Visual Studio right here and do your development. What we're going to do is run Forge. So we started up, and I'm going to log in as a user inside of Forge. So one of the things I want to call your attention to is the status window. This is showing us which DLLs got loaded. So actually there's 5 different DLLs that got loaded here. And by changing these DLLs, you get a completely different simulation. One of those is the Unreal Engine option DLL, which also then loads the Unreal Engine game. So we have a game DLL, and you get to pick your game in the launcher settings. So you can have different games loaded and pick which game you want. This picks which Unreal Engine DLL you want to use when you have the Unreal Engine option enabled. So I'm going to go load up a scenario that's actually similar to that. Let's see, where is it? Right here. So the first thing I want to show you here is that we have the Unreal Engine. This is actual Unreal Engine view. It's a view being drawn directly by Unreal Engine. So everything that Unreal Engine can draw can be drawn inside of here. This is actually a 2D top-down view of the same Unreal Engine world. So we can display a 2D view and a 3D view simultaneously. And what we have in here is a bunch of different players. All these players we call them units. They so I can zoom way in on the building and get real high resolution version of things. I'm doing level of detail when I do that. These units are units that I create in Flames, and this is probably one of the biggest, right off the bat, one of the biggest things that Flames brings to the table. In Unreal Engine, if you want to build a player, you use the Unreal Engine editor, you create the player, and then you rebuild the game. So you hit build, and it may take quite a while for that game to build. And every time you want to change something about that player, or add another player or move things around, you have to rebuild the game. With Flames, you build the game, you put all the classes in it for the game, but you don't have to build any players. All the players get built inside of Flames. Some of these are hybrid players, but these players get instantiated directly in the game. So I'm going to show you how I do that. I'm going to go to the ATV. So here's a couple of players. That's these guys right here that are in the game. And I've got it just a 2D icon representation of those guys. So I'm going to create another one. I'm going to go here and say new unit, and I'm going to create another ATV. And I'm going to call it ATV 2. And I'm going to give it a waypoint right here, and I'm going to say finish. And so I go back to Unreal View, and now I've got another ATV. So I didn't have to rebuild the game. It was just purely done in data, got instantiated in the game automatically without having to rebuild anything in Unreal. And I'm going to actually undock this view so I can see it simultaneously. Oops, it keeps docking where I don't want it to dock. So if I move that guy around, he moves immediately, right inside of the game. So I can create as many guys as I want, hundreds of them, thousands of them. And so it's all done through data. So this actually makes game creation much faster. So that's the first thing that we bring to the table. The next thing is the modeling. Again, Unreal is in our opinion, it's an amazing product. Just in the more I work with it, the more impressed I am. But it's particularly good at modeling things that move on the ground. So I'm gonna put here, put these guys out here. So it does ground motion really well. It's not as easy to do motion of air vehicles in Unreal Engine as it is to do that in Flames. Flames has a little bit easier development environment for creating models of missiles and rotary wing aircraft and fixed wing aircraft. So that's another thing that we bring to the table. Plus, Flames brings to the table being able to model munitions, comm devices, command and control, electronic warfare, jamming, radars. All that stuff is all available in Flames. Indirect fire, artillery, that can all be done inside of Flames. And the end result is you still get a game that has all that stuff in it, but you're working in a development environment that makes some of that development a lot easier. It's a lot more straightforward to do. So you get the best of both worlds. You get all the power and all the strengths of Unreal Engine merged with all the power and the strengths of Flames. And you really don't have to sacrifice the capabilities of either system. Everything you can do in Unreal, all the terrain that you can do in Unreal is all fully accessible inside of a game that you would build to be used inside of Flames. So I hit my time limit. I'll go ahead and just stop this because it gets kind of noisy.
Hey, Brad. Can you hear me, Brad?
I can, yeah.
It's Murray.
Hi.
Can you talk a little bit more about the pilot cognition model? I thought that was really interesting when we were working with you last fall, how that can really be built up to essentially an AI.
Yes, thank you, Maria. I'll be happy to do that. As I mentioned before, all Flames units have this cognition model, and that is modeling the human behavior of a given player. And that is really powerful. That is basically the equivalent of the AI controller capability that's inside of Unreal Engine. And all of our units have a cognition model on them. So if I go to the composition, here's a civilian. He's got 3 different cognition models on him. That V-22 Osprey, he's got 4 different cognition models on him. The main one here is the rotary wing pilot that we're using for that guy. So and the ATV has a ground vehicle driver. So you can build. So I'm going to go here to the ATV driver. He's got a bunch of different commands that I can give to the driver to tell him to move to, and if it was let me do the ATV. So he's got a whole bunch of different things that we can tell this pilot to do: pause, locate, and do an orbit, hover, flying formation, do formation flying. If this was a fighter aircraft, we would have different maneuvers and fighter capability. It can search for its own targets. It can engage targets, launch missiles. The Flames cognition model is really, really, really powerful. And you get all the abilities to do that, but you get the strengths of having the platform model being done inside of Unreal Engine. So all of these players are all being controlled by Flames cognition models. So was that a good enough description, Murray?
Oh, perfect. Yeah, I knew, I remember being impressed with it the first time I heard about it, and I just thought other people should hear that also.
Good. Thank you for bringing that up. So I will open the floor up now for more questions.
I think we may have lost. I think we may have lost a couple of people due to the lunchtime constraint, but that's all right. I am curious about loading new terrains and how those things get brought in. Could you elaborate on that a little bit more?
Yes. So this terrain is coming straight from the game. So anything that you build in Unreal in the game, wherever you get your terrain from, however you're used to doing it. You remember, Tal, you guys built a really cool Afghan terrain escape for us for the ITSEC demo. Then that's what we showed in that video. What I just showed in that video earlier. Anything that you build in Unreal, when you cook the game, it shows up inside of Flames. So whatever you're used to doing in Unreal, you just keep doing it the way you're used to doing it.
Okay, very cool.
And then the vehicles, like you were saying, Brad, the vehicles are really interesting, the ground ones, because remember we had to dampen down some of the suspension because they act the way they really should when they're going over bumps and hills.
Yep. Yeah, so these vehicles are pretty much standard Unreal Engine actors. They get built the same way. And what we have is a way to actually put blueprint functions on there in Unreal Engine. And then we can call those blueprint functions directly from the Flames cognition models. So for example, on this unit, this ATV that we had here, when we were telling it to move to a waypoint, so we've got all of its motion set up here, and a bunch of different waypoints that are on here, or that other one that I did as I'm moving him around and telling him to move, and I can add more waypoints to it. Let's see, let's remove that. Put another one in. It's really easy. These commands to move to waypoints are ultimately calling blueprint functions on the ATV. And so then inside of the ATV, inside the Unreal world, your Unreal editor, you write a blueprint function that can take a command that says move to waypoint, and then you move that vehicle using the physics capabilities of Unreal. So whatever kind of control over the vehicle that you want to be able to have from Flames, you just write blueprint functions that can be called from Flames to give it that control. And then the cognition model will then be able to direct that player to do whatever you want it to do.
And Brad, if I could chime in, where I find this capability really interesting from my former perspective as government program manager for training systems, is the end users and the DoD's need to have really massive numbers of entities in a battle simulation, but to have some of those rendered in very high fidelity when you have a sensor flying over them or an actor, a human in the loop, represented in Unreal, that's in direct visual contact. You want to see it exactly as it is. And that's always been something out of reach, because the scalability and the way the military uses CGFs and SAFs versus what we wanted to see in terms of cinematic realism for the visual rendering. So congratulations. I think this is a tremendous capability.
Yeah, I think it's kind of a marriage made in heaven. This incredible capability of Unreal, and being able to link that in with what we have in Flames, it kind of just opens up all kinds of new capability, new possibilities.
I had a question as well. How you add the path for the vehicles, are those always linear, or do they have an option to be like on a curve?
Well, you have complete control over that. So the way that we implemented this particular guy right here, we built a blueprint function that allowed us to give it a point to move to. And so that particular blueprint function just moves to a point, and then the path is defined in Flames. So you don't have to define the path in the game like a spline or something like that. You can define it inside of Flames and add just as many waypoints as you want. So that we could again, you can just, so the Unreal entity itself only needs to know how to move to one point at a time. And all of the AI control of which path you're going to is all being done inside of Flames. And we just pass a low level 1 point at a time down to the vehicle. Okay. Now, if you wanted to, if you wanted to make a way to tell it, I want you to move on a spline, you're fully free to do that, because there's no restriction here. This is just blueprint functions. You define whatever input parameters you want for those blueprint functions. There's no constraint on that at all. So you can build into your vehicle whatever kind of functionality you want to have, and then whatever kind of commands you want from Flames to be able to control that functionality.
Thank you.
One of the things that we can do really pretty well inside of Flames is moving vehicles along a road. We have like a road network model that does pathfinding, and we have a lot of cognition models for how to drive on a road. We haven't found yet a lot of road movement stuff in Unreal yet. Maybe it's there, but we haven't found it yet. So one of the things that we're planning on doing is continuing to use our cognition models for driving on a road, but that will all be done inside of Flames. The individual Unreal vehicle will just be given 1 point at a time. So we'll be giving it little segments of the road to drive around, and it'll do real sophisticated urban driving, but all the driving logic will be done by Flames cognition models. The Unreal Engine model will be very simple. We'll just give it 1 point at a time. or you'd have the option of saying, well, I'm going to put all the roads directly in Unreal, and I'm going to build all of the AI logic for driving on roads in Unreal, and implement it all inside of there. You have the flexibility of doing it either way. Daniel, what kind of things are you doing with Unreal these days?
Mostly simulation. One of the things that I was playing around with was actually importing ACMI files from like a TAC view, which you can make ACMI files from different games like DCS. And I was just creating a player similar to kind of how Forge works. And so another thought I had was actually thinking of a way to import the ACMI data into this, so that way it would auto-generate like the paths and everything you have, so you can just load in some of those scenarios that they might already have.
Tell me, I'm not sure I remember what ACMI stands for.
You got me there. I just know.
Is it ground paths, ground tracks, or air tracks?
It's both.
Okay.
So it does ground and air. I'm trying to see what ACMI stands for so I can tell you.
Yeah, so that'd be a perfect application for Flames. It'd be very, very easy to pull in. In fact, we do that. We have applications that already do stuff like that. We're not using ACMI files, but very easy to import that stuff. And then this route that you see here in 2D, instead of me creating that manually, that would get created automatically from the ACMI data.
Mm-hmm.
And then the Flames cognition model would take those points off of that route. And the Unreal vehicle, again, it wouldn't have to be any smarter than what it would take to just move one point at a time.
Yeah. And in the movement part, does it have a option for altitude, and does it calculate it? So if you used like can you use like a globe terrain, or is it all going to be a flat like traditional flat terrain?
Definitely globe. Yeah. Flames coordinate system is a full three-dimensional of the whole globe.
Okay. And
the
how do
origin
you?
Of the flame, the origin of the Flames world is at the center of the Earth.
Okay. So how would you calculate like height above sea level? Because most of the options I've seen for other things have just been actual just elevation, where it just casts from the ground and just does it from there. But if you're tracking from height above sea level, it takes just a little more effort.
Yeah, that's all done. We do that stuff in our sleep in Flames. There's all kinds of support for doing that. We're used to working in either above ground level or mean sea level coordinates, and easy to translate back and forth. It's just built into the framework to do that.
That's great.
That's an interesting point you just brought up. The Unreal world that you build, if you put curvature in the terrain in Unreal world, you'll have curvature in it. If it's flat, this particular terrain happens to be flat. But one of the things you do when you set this up is you say, where do you want that flat Earth to be in the real three-dimensional globe of Flames? And so we have it positioned in Southern California, because this is actually a Camp Pendleton database. So we have the right coordinates there. And all of the coordinate conversions between the XYZ of an Earth-centered system to Unreal Engine world coordinates is all done automatically by Flames. You don't need to use the georeference plugin that's in Unreal Engine. We do all that on the Flame side.
Okay.
So all of your coordinate data that comes in, Flames will handle that all very, very naturally, and it'll automatically convert it to all of the right coordinates that would be used in the game. That's just all done automatically. And this particular guy right here, I pull him up. In fact, I could he's got altitude on his points.
Yeah, I see that.
Because this is an aircraft. So he starts out on the ground, but he takes off and flies to altitude.
Awesome. Do we have any more questions? Because we have about 5 minutes left. Okay, cool. I'm going to go ahead and yeah, Walt, what's up?
Yeah, I just wanted to say I'd very much like to have access to the recording of this to share probably the large number of people that are attending HALT today and had other conflicts, because I think there's a wider audience that will be interested in this.
Mm-hmm.
Absolutely. I will make sure that everybody gets access to this. So yeah, we'll definitely be able to have this shared with people. Okay, well, with that, I'm going to go ahead and stop our recording. But first, I just want to say thank you so much, Brad, for joining us today and for sharing all of your expertise on this incredible project and product that you've developed. It's so cool to see Unreal really making waves in the training, modeling, and simulation space. So thank you so much.
And I hope it's particularly satisfying for you and Murray, since you guys had a hand in making this possible.
Absolutely.
It is really nice to see it working. Yeah.
Yeah. All right, I'm going to go ahead and stop recording right now.